Welcome everybody to the first edition of A Day in the Life of an Incident Responder with CloudHash Security. This will be the first part of a multi-part episodes where we'll be walking you through certain incidents that are common throughout the environment, and we're going to use CloudHash Security to locate them and eradicate them. So the assumptions that you have in our little environment here is that we're running an EPO framework. We have DXL running and installed in the environment. Of course, you have CloudHash Security with RapidQuery installed. You have HIPS and AV on your machine, as well as you have the email gateway, McAfee Active Threat Defense, your IPS, your NSP is your IPS, your ATD is your malware analysis, and you have Cuckoo Sandbox running that we can do some malware analysis. We also assume that you have run a complete baseline of your journal, and you have all your data points being captured locally at the endpoints. So we have our little mock incident response portal. We see we have 4 incidents open today, and we're going to run through each one of those individually. So here's the list of the 4 that are currently open. We'll run through them one by one. Just to give you an overview, we're going to be looking on the network for a known bad email address that was sent to one of our users, and we're going to search our environment and find those emails, as well as respond to the incident that contains that from that email. We're also going to be searching the network for a known bad IP address to see who's communicating with it and respond to that incident. We're going to use a existing CloudHash signature, which uses a known bad pattern from our red team, and then finally we're going to take an open source incident and see if we are affected by it, as well as create a signature around it. So let's dive right in. So our first one here is the known bad email sender. We see that our email gateway has reported that we've received 4 emails from a peggy.l.olson.hr@gmail.com. This email address has been known to be sending bad email addresses with virus-laden attachments. So what we're going to do is we're going to dive in and see if anybody's received this email. Now, could it be that the incident is not there because our email gateway caught it? Yes, that is likely. But if our email gateway was down, or if the email came in from a personal account, we might still be affected. So we're going to go ahead and move into the EPO console and see if anyone has received an email from this email address. So let's switch over to our EPO console, and we're just going to search our environment to see if anybody has received an email from the Peggy Olson email address. We will target our entire enterprise and ask that question. So all we have to do is type in peggy.l.olson.hr@gmail.com. That will now search the enterprise to see if anybody has received an email address or received an email from that address. Now we see we have 2 emails here. We're going to drill down with this one here. You see that we have an attachment name of company buyout information.pdf. If we scroll down here, we also see that the email has been read. So we're going to say that we need to investigate further because this email is read and had an attachment. So what we're going to do is we're going to see if anybody has a file out there with that name. We go back to our console here. We're going to ask the enterprise, hey, does anybody have a file with the following name? We're going to target the entire organization, and we're going to paste in that company buyout information. Now this is a regular expression signature, so we need to escape our spaces and our dots so that it's more literal, and hit OK. Here you'll see that we have one file in this user's downloads folder. If we drill down into here, we now see that we have the metadata surrounding the file. We have the fuzzy hash, and we're going to use that fuzzy hash to see if there's any files out there that are like this PDF document, meaning that maybe they're similar, but it's still somewhat the same file. We go back to our console. We can select that row, and we can ask the enterprise to find similar items. So under our similar items here, you'll see that we have 3 files out there that are similar to this one. So we're going to go ahead and say that this file is probably pretty bad because it's always appearing in users' downloads folders. So we're going to select that file and we're going to pull it back from the local machine to run some analysis on the file itself. So when we hit pull file here, it actually pulls it back to your EPO server where you can then save it locally, unzip it, and then analyze it. The analyzing files is outside the scope of this instructional video, so we're going to assume that we ran against it, found that it was writing registry entries to the registry that was run32 DLL and some JavaScript. So what we're going to do is we're going to search our enterprise to see if anybody has that pattern in their registry. So we'll find the registry question that has the data value. We'll target the enterprise and ask in regular expression if anybody has run DLL32.exe with JavaScript as the command and then anything after it. We run that against the enterprise, and this in a few seconds will let us know if anybody has that registry value in a registry data value in the registry. This takes a few extra seconds because searching the registry for regular expression does take a few seconds. Okay, so the registry value came back. We're going to drill down into this answer. You see that we have run DLL32.exe with some JavaScript in there. Now, if we went ahead and researched this value, we're going to find that it's actually associated with a Powlinks threat. Now, this Trojan itself is a memory-only resident virus, which means it does not create any files in your system, and it is sustainable on your system because it executes PowerShell directly from your registry run key. So this thing's pretty bad. So what we want to do now is determine how this thing even get on there. So because it seems like the origin of this file was a PDF, it's likely to assume that the Adobe Acrobat version reader is actually old. So what we want to do is we actually want to drill down into this machine itself and see what version of Adobe it's running. So what we're going to do is we're going to go and we're going to search our enterprise for that machine and then target that machine with a question just to ask, hey, what products are currently installed on that system. So under incident response, we're going to ask that question, ask a question against the selected machine, and we're just going to simply ask it what products are currently installed. We'll target that one machine and we'll ask the question. So now if we drill down into that all products question, you see that Adobe Reader 10 is currently installed on that system. So from here we actually want to upgrade that asset from the Adobe Reader, and we can do that directly from CloudHash. But we actually want to target the entire enterprise. So what we're going to do is we have created a question which downloads the latest version of Adobe Acrobat Reader and installs it if it's currently installed. So since that question is already created, we'll go ahead and find it, and then we'll go ahead and target the enterprise, ask it, and then the entire enterprise will get upgraded if it's less than version 11. So after we ask that question, we upgrade the asset. We actually want to go back through and start to clean up this incident. So we'll go back to our registry value here. We select this box. We say, hey, go ahead and remove that registry key from the system. We're also going to want to go back and find all the files that we searched for and go ahead and delete those as well. So we'll go here and we'll hit delete as well on all these files and remove them from the system, so that this now the system not only has been removed all the malware, but it's also been all the products have been upgraded. So we've not only cleaned up this incident, but we've also ensured that it doesn't happen again. So let's move on to our next incident after we clean up our current incident here. And to recap, we got reported of a bad email address. We actually searched the enterprise to see who received that email. We found that multiple users had received the email. we found that the file contained in the attachment was bad, so we had to search and see who else had that file on their system. We found the file itself. We found registry values containing JavaScript, and we also found an old Adobe version, upgraded Adobe, as well as removed the file system and made it clean again. So if we look at our next incident here, the IPS is reporting that a known bad IP address associated with known bad malware is being communicated with. 1.45 is our bad IP, and we see that 1.23 is the one that's communicating with it. Now, unfortunately, if you look at our network diagram here, 1.23 is a firewall from a company we have recently acquired. We have migrated all of their EPO servers over, so because we can reach the internal network, we're going to have to look and see, hey, who's communicating with this known bad IP address of 1.45. So we're going to navigate back to our incident response page under EPO and just ask to see who's talking to this IP address. So we're going to go ahead and ask the organization, hey, who is communicating with 192.168.1.45? Ask that question and we get responses back. As you can see, 1.12 is currently communicating with that IP address, and we need to investigate further. If we drill down into this row, we see that a file named lsas.exe.exe is currently talking to that IP. That is not a good sign. So what we want to do now is actually investigate this a little bit further and find out a little bit more information about that file. So if we go back into our incident response page, we can go ahead and say, hey, who else has that file in on their system? So we just want to do a quick file name search to see if that file exists on an enterprise anywhere else. Our results come back with one file with this fuzzy hash, this MD5 hash. So what we want to do is that we actually want to see if there's any running processes. Well, we know there's a running process based on the connection, so let's go ahead and pull that process back by asking the question of a named process. So we see this machine has it running, and what we want to do from here is, first thing we want to do is pull it back to see, first of all, investigate it ourselves. But what we can do is actually drill down into this file itself here and use the MD5 hash and just go ahead and search the internet to see what if this was a known virus or if it's something new. So if we search the internet for that MD5 hash, we come back with netcat, and according to the internet, a lot of AV picks this up. So why is RAV not picking this file up? Probably because the AV service has been shut down. So let's go ahead and ask if this machine, if AV is running. So if we take this asset, we're going to go ahead and drill down into that asset to see why their AV is not running. So we'll target that machine to ask it a question. I'm just going to ask it what services are currently installed on that machine. We ask the enterprise. Go ahead and filter down here and search for the MC Shield service. We see that it is currently disabled, so this is the reason why the virus is able to continue to communicate. So this next step here is obviously to re-enable the service and go ahead and start that service. So we're going to select this box. We're going to say, hey, go ahead and enable that service, and I am sure I want to do that. From here, after the service is started, we can then re-enable it. We can then start it. Because it's been shut down for a little while, what we're going to want to do is actually take that service after we start it and update the AV definition. So we have a question already created, which is a PowerShell script that gets executed and pulls the latest AV defs locally and then applies them locally, and then starts a new scan so that we can find these viruses. So We're going to go ahead and ask that question now. We're going to ask, what AV defs currently are out of date. Ask which hosts don't have up-to-date AV signatures, and we'll ask the enterprise that question and send that out. This will automatically upgrade. Now, when the AV definitions are updated, it should actually pick up that virus and shut it down. But because we want to make sure that this happens correctly, what we're going to do is actually go ahead and tell that process to kill right now. We kill that process. We tell it we are sure, and then that process dies. When the AV definitions are updated, it'll go ahead and quarantine that file. And of course, we could do that directly from here and delete that file. But we're going to go ahead and let the AV take care of that for us. So now that we have cleaned up that incident, we're going to go ahead and shut all these questions, or delete all these questions, and clean up our space here so we can work on our next incident. So if we look at our next incident, we're going to go ahead and see that our night shift here has reported that they saw the signature red team reported pattern flag in our event log. Now this signature is actually looking for, based on a red team exercise, that for a new file being created in a www root folder on an IIS site. Essentially, our website here is an e-commerce site that can't be brought down, and there's a critical patch that needs to be made on the system itself. And while the vendor is working to fix it, we wanted to go ahead and just monitor for this specific pattern. It's actually not a bad signature. www root folders or any sort of website doesn't change very often, and if you wanted to monitor and look for changes to that folder, is probably pretty smart, since it only happens maybe once a quarter during patches. So the event flagged an iExplorer.exe file being flagged in that folder, and so we want to go ahead and start investigating this. So let's move back to our EPO console, and actually what we want to do is we actually want to see if there's any other files being created in that folder as well. So we're just going to go ahead and ask the question if we're going to ask for the contents of a specific directory for our email server. So if we just search and we say, hey, what's the contents of our www root folder on that web server? We ask that question and we get the results here of, now we see that this iExplorer.exe file really is in the www root folder. So the first thing we want to do is actually pull that file back to find out what that file is. So we'll pull that file back. We'll go ahead and save that to our hard drive. And what we actually want to do is investigate this file itself. You'll find that the file is named iExplorer.exe, but it's something that's not signed. So while we don't know what the file is, we can do an easy CloudEdge signature that looks for the file name of iExplorer.exe. And to reduce the amount of false positives we get, because that is a known file name, and it could be placed anywhere in the enterprise and on your hard drive, the real iExplorer.exe is always signed by Microsoft. So our CloudHash signature looks for iExplorer.exe, but it has to be unsigned by a vendor. So we have that question already created here, and we just want to ask that question for unsigned iExplorer.exe. Essentially, we're just asking the enterprise to find that pattern and see if it's out there. So when we ask that question, we should get responses back for that file itself, as well as any other ones that are out there in the enterprise. So now we see that under the documents folder we have an unsigned iExplorer.exe in the user CHS folder. Now we also want to make sure that this file itself, to see if it's actually running in the network. You'll see we actually have a bunch of files here, one in the Commons folder, one in the C drive, one in this user's documents folder. So if we want to, we can see if there's a process running in this with this name, and we'll see if that comes back with anything. Not looking like iExplorer is running right now. So what we're going to actually want to do is see who's actually communicating with that host. We'll just see if this machine has any open connections to that web server. So let's just ask again, who's talking to that web server. We'll ask the entire organization, hey, who has an open connection to our web server. And here you see the 1.12 machine has an open 445 connection to our web server. Now we would expect port 80443, but we don't expect file share to be open to that server. So our next step here is actually to see what shares are open on our web server. So let's just go ahead and ask, hey, what shares are currently open on our web server? And we look and we see that we have this subdirectory right now running on our system. We're going to go ahead and want to find out what files are inside of that share. So we go ahead and we ask a question for the directory contents of that subfolder. Now if we look, we're going to find that we have some sort of healthcare document, Word document inside of that file. So let's go ahead and pull that back and see what the contents of that file are. So if we go ahead, we ask it to pull a file. We're going to download it, and we're going to unzip it, and we're going to open that document. Inside of that document, you're going to see that there is an SSN inside of this healthcare form, and we're going to actually want to see, hey, is there any other files out there that have this specific social security number? Because we're going to want to contact this user. We're going to want to know, when we advise him on what to do, we're going to want to find all those files so that he can clean them up. What we're going to do is we're going to ask the enterprise if anybody has that SSN in their inside of their files. So we're going to ask the entire organization and say, hey, who has the social security number inside of a document? So you see we have all these files inside of zips, inside of other Word documents. We have account closure, some healthcare forms. We also have some sort of education benefit form. All have this social security number in it. Now, we're going to want to advise this user, hey, not only do you have sensitive PII information on your desktop, but you also have, it's also been released via some malware. So what we're going to want to do is we're actually going to want to contact this user directly to notify him of that information. Now, from a corporate environment, that's pretty hard to contact a user because you don't really know who it is. So what we're going to want to do is actually quarantine this user from communicating with the internet, and then use Cloud Hash Communicator to actually notify him or her that their system's been compromised and that PII information has been released. So if we go to our policy, you'll see under Cloud Hash Communicator that we have changed their desktop to read that their PII information has been found and they need to contact security. We also have released a desktop message as well to them directly from EPO, letting them know they need to contact the security office to get their PII information cleaned up. And you just simply do that by taking the host itself and dragging it into that quarantine group. And once you've done that, their desktop will change, their environment will change, they'll get a pop-up message letting them know to contact security, and they'll also lose their internet, so they're going to want to contact you. All that process helps you get the user involved in your incident response. So from here we can actually clean up the file itself in that www root folder. We can kill any processes that are running. We can get that iExplore.exe off of the system, and hopefully that system will get patched sooner than later. But now that you've cleaned it up, you've notified the end user, you've done an end-to-end incident response, we can actually close this incident out and move on to our next incident. So let's browse back to our portal here and work our fourth and final incident. So here you see that our Shift has reported that there's a new threat found with a specific pattern. This pattern is actually looking for what they call as drive-by information. So with this pattern, there's a bad process running that simply just looks and monitors your internet cache folder. It looks for specific file patterns inside of that cache folder. Once it finds that pattern, it actually will rename that file to an exe, and then execute that, and that image that was pulled down from the internet is the actual virus. The only thing the monitoring is doing is just being able to copy it and get it to a different folder, rename it to an executable, execute it, and then delete it. A pattern like that, if you submitted it to an AV vendor, would actually come back clean because it's not really doing anything bad. But because the image files are being hosted from known good advertising sites, this sort of attack is hard to capture. So what we've done is we actually have created a CloudHash security signature that looks for all the EXEs on your system, and it also looks for all the image files in your system, and then it compares those two objects together to see if any executable files have matched any image files. Now the nice thing about CloudHash is because we give you that historical view, we can see this pattern of attack even if it's happened in the past. So it doesn't have to be an active attack on your system. This could be something that happened 2 weeks ago, and because this is a new pattern that was found recently, it's more than likely that it's not going to be something that's current on the system. So we've created the policy object and we've deployed it out to the enterprise, but what we're going to do right now is actually search our systems to see if that pattern exists anywhere. So if we go back to our console, we're going to have, we've already created that question that says, hey, who has any JPEGs that match EXEs in the environment? We're going to target the entire organization. We're going to ask that question, hey, who has this pattern? Now typically if you wanted to search your entire hard drive for either of these file types, it's going to take a little while, and then to compare those two objects together will take a very long time to see where those MD5s match. Luckily for CloudHash, this is a very simple operation, and it actually happens within seconds. So you see here we have multiple files here that have that matching pattern of EXEs matching JPEGs. So you see you have this update1.exe with matching the pesticide.jpg file. So from here you can actually investigate this exe, pull it back, and if it's a running process, stop it. There's multiple things you can keep drilling down into here, but for the scope of this session, we're going to go ahead and call this a done incident. So that actually resolves our last incident. You'll see we have everything closed out. We did it in just a few minutes. If you have any questions or comments, you can go ahead and email me at joe.peruzzi@inforeliance.com, or you can visit our website, cloudhashsecurity.com,